Today's learning target is I can find missing measures of similar figures and use scale factors to solve problems. Today we're going to be talking about similar figures. Now when we're dealing with similar figures, so these two are going to be similar. They have the same shape and the same angle measurements. Okay, so like this angle would be the same as this angle, the measurement, but they don't necessarily have the same size. We can see this one's larger, but we can see that all the angles, they'd be in the same measurement. Okay, so those are similar figures. And this little sign right there, that's how we show that something is similar. So this is saying that ABCD, this figure here, is similar to EFGH. And the reason it's labeled as this is so point A would be this similar to point E, point B to point F, so that way you can figure out which part of the shapes they're talking about. Now, if something is congruent, that means they have the same shape and the size. So to show congruent, we use this. Oops, is it going to let me do that? We use this symbol right there. So this is saying angle A is congruent to angle X. So there's angle A and there's angle X, and you can see there's one line there, that means those are congruent. Now B is congruent with angle Y. So there they show two lines to show that these two are congruent. And then Z and C are congruent, and you see how they show that. When I have similar figures, like I have here, similar figures are proportional, and so I can use that to help me to find missing measures, like I'm going to be doing here. So I know that this angle right here, AC, is going to be proportional to this measure right here. So if I was trying to find this, I would look at this and I would put 4, and this is going to be, I want my proportions here. I want these to be equal. Okay, now I know that it's 4 on this measurement, that's going to be proportional to 12 over here. And now I have, in my first triangle here, 6 right there is going to be proportional to X. Okay, now when I look at this, I just say, how do I make this proportion true? So I times this by 3, so I'd have to times this by 3, so X would have to equal 18, and I'm dealing with centimeters. So in this problem here, I have set up my proportion down here. We can see I'm trying to solve for X, so I created my proportion here, so I've got my 5 over 12, and I want that to be equal to or proportional to X over 8. Now, this one doesn't work quite as easily as the last one, where I can't quickly figure out what I multiply by 8 to get to 12. So now what I want to do is solve for X. So remember, when I solve for X here, I'm going to times these, so 5 times 8 is 40. And over here I get 12, that's going to be equal to 12x. So I'm going to divide each side by 12 to get x by itself. So you can see over here that I've solved that problem, 40 divided by 12, and I get 3.3 repeating. So I know that as a fraction would be 3 1/3. And let's see, I am looking at centimeters. So x equals 3 1/3 centimeters. Now we can see in this one that we're going to be finding, they want us to find what the length of this measurement is here. But you want to be careful, because notice these may not look like they are similar. However, we can see by the listings here that point S is similar here. Okay, here's the 3 little lines. That's going to be lining up with that point. This one would be right there, and this point would go right there. So this is just flipped here. And so if we flipped it the other way, so if we kind of were able to flip this, it would actually look the same. So we have to be careful on this. So again, I want to find a proportion. So to go from this angle to this angle, it's 49. Okay, so I want to find that same measurement in this one. So I want to go from here to the 3, and that's going to be the D. So I want that proportional to that one. Okay, and now I also know that from this 3-lined angle to this angle is 28. So that would be right here with this one. Okay, so here it's 28. I'm going to put that in with that one. And over here it was 4. So now I could look at 4 times what would get me 28, or I could do 28 divided by what gets me 4. So I'll just do that. And I know that 28 divided by 7 equals 4. So I'm going to do 49 divided by 7, and that would give me 7. So D is going to equal 7, and it looks like my label is going to be feet. Alright, in this problem here it says an architect is designing a decorative window for the entrance of a new office building using similar triangles. So if triangle ABC, let's see, where's that? It's right here. ABC is similar to DEF, okay, then find the length of segment DF. So here's DF, so I want to find that length. So because these are similar, I know that they're going to be proportional. So I can see right here, this triangle, I'm going to take what I know here. Okay, the sides are both 18. Okay, that means they're going to be proportional to these sides right here. So I'm going to write down what I know here. So I've got 18 is, and that's inches. All right, and I want that to be proportional with the other side. Now let's take a look there at the other side, and I know that, let's see, this would be the proportional to that. So that's going to be 9 over there. Okay, and now I'm looking here. I know this measurement is 25.5. So I'm going to put that there, 25.5, and that's proportional with this, which is what I'm looking for. So I'm going to put X. So now I'm going to take a look at this, and I want to take a look to see how do I go from 18 to 9. That should be inches. That's inches too. And I know I divide that by 2 to get there. So I'm going to divide 25.5 by 2, and that's going to get me my measurement there. So you can see I've done that right over here, and so I can see that X equals 12.75, and I'm dealing with inches. So there's my answer.